Yeah, in this video we'll talk about merging, that is combining two sorted lists into a single sorted list. Merging is a binary operation. It needs more than one array so that it can combine them into a single array. Likewise, merging, there are more binary operations on an array. Quickly I will tell about them. One is append, concat, compare, copy. These are some of the binary operations on an array. Here you need more than one array. Like appending an array. Already we have an array and there is suppose free space. We want to add these elements followed by this one. That is append. Concat, that same thing. Combining these two arrays is concatenation. So it may be done in third array, like all the elements of array A, then all the elements of array B followed by that. Appending means that array is updated. Concat means that may be in some other array. It's the same thing. Concat and append are same. Comparing two arrays, comparing whether they have a same set of elements or not. So one by one we have to compare the elements from two arrays. Then copying. So if you have an array of elements and there is a free array, empty array, we want to copy all these elements in this one. So this is copying. Now likewise we have merge. Now let us see what is merging. Merging can be done only on sorted list. So first array is sorted and the second array is also sorted. And we have to combine these two arrays and get a single sorted array. And for merging, we need definitely third array. We cannot combine and store only in A or only in B. We need one more array, let us say C. Now how to combine them? Before looking at the procedure, let us say the number of elements in this array are M elements and this array are N elements. So that is having M elements and this is having N elements. Now we will combine these two and store them here such that they are sorted. So for that we will take index pointers I, J and K. I start from first index of A and J starts from first index of B and K starts from here. Now what the procedure we perform is a repeating procedure. So what we have to do? Compare A of I with B of J. Whichever is smaller, copy that one here. So if A of I is smaller, copy it. If B of J is smaller, copy that one. So right now A of I is smaller. So copy this the one. Then move I to the next element and move K to the next element. Then compare A of I with B of J. Now B of J is smaller. So copy this element 4 and increment J and increment K. So what we are doing here, I will write down a pseudocode for that one. Initially I is equals to 0 and J is also 0 and K is also 0. That was initial one. Then we are comparing if A of I is smaller than B of J. If so, then in C of K we will copy A of I. And we increment K as well as I. Otherwise, in C of K++, we will copy B of J++. This is what we are doing. So let us continue. A of I is 8, B of J is 10. So 8 is copied here, I is moved further and K is moved further. A of I is 16, B of J 10. So 10 is copied, then J is moved further. A of I is 16, B of J is 12, so 12 is copied and J is moved further and K also moved further. A of I is 16, B of J is 22, this is 16, this is 22, so copy 16, move next, move next. A of I 20 and this is 22, so 20 is copied here. I is moved, K is moved. Now this is 25, this is 22. 22 is copied. This is 25 and this is 23. So 23 is copied. then j plus plus, k is here. So j became 5 now, means it has gone outside the size of an array. There are total 5 elements. So j became 5 now, it means the second list B has finished. We should stop. We cannot compare now A of I with B of j. Then what to do? Definitely there are some elements left over in A. Copy them. From wherever I is, from that same place, start copying the remaining elements. Suppose I have more elements, copy all of them. And definitely at least one element will be left over. So in our example, here we got one element left. If suppose this is not 23, this is 28, then this will left over, that 25 will be copied. So in any one of the list, at least one element will be left over, so we have to copy that element. So copy that 25 here. That's all. This is the merging process. Now let me complete the code. See, I was comparing and copying every time. Repeatedly I was doing. So this was happening while I is less than m and j is less than n. Compare and copy. But we have stopped when j became equal to n. So when it is less than n, we were continuing. When it is equal to n, we stop. We have to stop either if the first list ends or second list ends. Means I becomes equal to m or j becomes equal to n, we have to stop. Okay, we have stopped. Then what we have to do? Copy the remaining elements. If in the first list, copy the remaining. If in second list, then also copy the elements. So for that, I will write on the code here. For wherever I is, let it be there only. I less than m, I plus plus, c of k plus plus assign a of I. This will copy the remaining elements from first list. If suppose there are some remaining elements in the second list, then copy j less than n, j plus plus and c of k plus plus, copy b of j. So this is the code for merging. So at last I will copy that 25 also here and move I and k also and stop. We have combined two sorted lists into a single sorted list. And this single sorted list is having total m plus n elements. Now, analysis. What is the work done? Comparing the elements and copying the elements. Here we prefer copying of elements. So how many elements are copied? M elements from here, n elements from here are copied. So total time taken is m plus n. So it is written as theta of m plus n. See, so far I was writing order of, but this is a known one. We use a theta. We can use big O or omega or anything also, but usually theta is used. So I will explain you what is theta afterwards. So the time taken here is theta of m plus n. Total m plus n elements are copied, and this is the first time we are giving the time complexity in two variables, m and n variables. So this is a notation for merging. Wherever you see m plus n, then definitely there is merging used there. So m plus n is for merging. So that's all about merge process.